let's do 5. All right. This will work because it looks just like what we took in our notes right now, so it'll apply basically the same way. How many relative maximums do I have? Show me on your fingers real quick. How many maxes are there? Ooh, maxes, specifically maxes. Yes, there's 3 extrema. I got 1 max. Where is my 1 maximum at? C, which is at 0, 1. So I have a max at 0 because I'm only looking at the x values. I really don't care about the y values. How many minima do I have?
2.
I got 2 of them. Here's one of them, point B, which is at -1, -1. Then I got another one at point D, which is at, it's not exact, but I'm going to round set. I'm going to call it 2, -7. Is that right?
Yeah, we can say that.
Now, you may have gotten real specific with your decimals and stuff. That's fine. As long as your intervals are set up the same, the number in them doesn't matter to me necessarily. Real quick, end behavior, super, super simple. Hopefully we remember. As x increases, what's happening to my f of x? Increasing. What about as x decreases, what happens to f of x? Increases. How can I tell that this is increases just by looking at the graph? Ben? Both arrows pointing up. Which means as I go onward infinitely to the left and the right, my function is always going to be going up. All right? Now my intervals. Increasing, decreasing, increasing, or decreasing. Well, first of all, let's figure out what these intervals are, and then we'll figure out which one's increasing and which one's decreasing. Okay? So just like the notes we just took, I should have a continuous, a compound, and a continuous. My continuous intervals are always going to be on the endpoints because that's where my arrows are, right? Okay? So this far left section over here is all my x values that stop at -1. Are they less than -1 or greater than -1 in that section? Look at this section here. Where is it at? On the left or the right? It's on the left. So my sign should be what? Less than. Okay. Now, is this section going up the roller coaster or down the roller coaster?
Down.
It's going down. So is that decreasing or increasing? Decreasing. X is less than -1. Now, I know I'm going to have 2 of each because I have 4 sections, obviously. So this next section must be increasing. Really, all you need to figure out is the far left section, if it's increasing or decreasing, right? Because I know that if this first one is decreasing, the next one has to be increasing, the one after that has to be decreasing, and the one after that has to be increasing, because it switches every extrema. Now this section in here obviously must be increasing then. It starts at -1 and it goes to 0. How can I write that as a compound inequality?
-1 is less than x, less than 0.
That's right. -1 is less than x is less than 0. And that's increasing. I hit point C. And I switch to a decreasing interval. This decreasing interval goes from 0 to 2. So how can I write that as a decreasing interval? It goes from 0 to 2.
0 is less than x, less than 2.
Perfect. I hit point D. I was decreasing. Obviously now I must be increasing. I'm increasing for all the x values
X is greater than
that are greater than 2. Again, this far right section is the only one with a greater than sign every single time. Okay, the far right section is the only one with a greater than sign if you're always writing your x on the left. Okay, just like I said in the notes, I could also call this section 2 is less than x. It's the same thing. And that's what I get. I have 3 extrema. I should have 1 more interval. That's 4. 1, 2, 3, 4. Sound good?
Yeah.
Any questions I can answer on number 5? How about we take a look at number 4? Now, number 4 is interesting, right? The line looks much simpler. That's not harder. It's easier. It is simpler. How many bumps do you see on this graph? I don't see any bumps at all. I just see a straight line, right? My mins and maxes are anytime I have a bump, whether it's a round bump or a sharp bump, I'm looking for bumps. There are no bumps here. So for relative maximum, I'm going to put none. What should I put for relative minimum though? Also none. End behavior, we treat it just the same. As x increases, what happens to my f of x? Decreases, thank you. Because this right arrow is going down. But as x decreases, as I go further on the left side of my x-axis, what happens to my function there? Increases. Okay? Now, for my intervals, this is where it gets tricky. I saw some of you guys on Friday say, oh, there are no increasing or decreasing intervals because there's no extrema. However, there's always one more interval than the number of extrema you have. How many extrema do we have here? 0. So how many intervals should I have? 1. I should always have one more interval than the number of extrema, even if my extrema are 0. That means I have one interval. Well, typically, if I'm trying to figure out if it's increasing or decreasing, what should I draw on the left side of my line? Not an arrow. Little roller coaster guy. Is he going down the roller coaster or up the roller coaster? Down. He's going down. So this whole function is decreasing. So for increasing interval, I can say none. There is no increasing interval. Now, for decreasing, we could do this the easy way or the hard way that I talked about last week. Which would you prefer, the easy way or the hard way?
The hard way.
Hard way. So, is this line, if I extend it, if I zoomed out of this graph, is this line ever going to hit a bump where it starts going up? No. So, it's decreasing always. Okay, that's the easy way. We can just write, it's always decreasing. Okay, Oscar did it the hard way because that's what we talked about, which is good.
Oh, the infinite sign.
Mm-hmm. So, mathematically speaking, if I'm always decreasing, what's the biggest x value that's ever going to be a part of this function? Biggest.
Infinite.
It's kind of a trick question because it's not actually going to be a part of it. But if I keep going to the right, if I look at my number line, if I keep extending this to the right forever and ever and ever, what am I going to...
Infinity.
It's infinity, right? I was going to say, what am I eventually going to hit? But I'm not going to ever hit infinity because infinity is not a number, it's a concept, right? So this function is going from infinity to negative infinity. And from that point to that point, that, quote unquote point, this function is always decreasing. So Oscar, what's the technical interval I could write for decreasing? Decreasing always.
Negative infinity.
Yep.
Less than x, less than infinity.
That's right. Or to be more specific, positive infinity. So this is the easy way, this is the hard way. I don't care which way you do. If you want to put it's always increasing, great. If you want to put it's always decreasing, great. If you write it in this notation, make sure you are doing it correctly. Okay? When we get into exponential functions a little bit later on in the year, understanding this concept of going towards infinity is really, really important. So if you understand it now, that's great. That mentally puts you a little bit ahead of the curve. But if seeing all this is like making your brain break and make you want to cry or something, just write it's always decreasing. Okay? What type of interval am I looking at in number 12? An increasing interval or a decreasing interval?
Increasing.
Increasing. On what interval is it increasing? Always. And it's never decreasing. Now I could say it's increasing from negative infinity to positive infinity as well. You can just write the word always. Okay, you can thank Ms. Fregoso for that. I was going to make you do this. She's a math teacher.
Thank you.
I was going to make you do this. She said she only makes her math 1 kids write always. And so I was like, all right. You can write always. Okay? Does number 12 have a line of symmetry?
No.
Nah. So again, we talked about that. This was my mistake. For this, we only want vertical lines of symmetry. Okay? Eventually in your math 2, math 3 classes, you'll have different lines of symmetry, but for right now, we're just going to stick to vertical. So like number 11, I have a line of symmetry at, what's the equation of this line right here?
X equals 2.
X equals 2. Right, that's a nice little line of symmetry. I'm pretty sure besides number 12, everything on the back has a line of symmetry, a vertical one, which is good. Does that make us feel a little bit better about doing this?
Yes.
No?
Somewhat.
That's crazy. Saying no is crazy.
That's really easy.